I thought for my next series of videos, I'd build up the Magnis software-defined radio, and you can see the board right here for that radio. I got this one off eBay, but there are other places out there where it is sold. This one was around about 45 bucks, and there are cheaper places that you can get this from. So let's just quickly walk through some of the specs of the radio. So the radio itself is a quadrature sampling encoder and decoder, similar to some of the radios that I've built before. The finals are a pair of RD15HV F1 MOSFETs, and you get approximately 10 watts output. The bands that are covered are all the ham bands, and in the kit you actually get a series of pluggable boards for the bandpass and low-pass filters. So just walking through what you get on the kit here. This radio is a software-defined radio in that it uses this onboard microcontroller right here, which is a Cypress CY832 programmable system on chip. And that microcontroller controls the local oscillator frequency using an SI570 as frequency synthesizer, as well as performing audio digitization. Note, however, that there's no onboard audio processing for phase shifting. All that happens off-board, either on a PC or Mac or Linux box, whatever, running HD SDR. So in other words, this isn't a fully self-contained radio. You do need to have software-defined radio software running externally. So here's that microcontroller that I was referring to, so CY8C32 from Cypress, and I'll include a link here to all the documentation I'm about to walk through. So this microcontroller also controls all aspects of transmit and receive switching, and that's done through relays in this case. And it also acts as the interface to the USB connection that is used to flow all the audio, either incoming or outgoing, from the HDSDR software that's running on your computer. So the other IC that comes pre-mounted on the board is the one you're looking at here, which is PCM3060 asynchronous stereo audio codec, and this IC is responsible for digitization of the sound, whether that's transmit on transmit or on receive. And you'll see as I get into the schematics that is done through an I2S interface between the Cypress microcontroller and the audio codec. Right. So just back to the board now, and note pretty much all of the components used on the board are surface mount components. Some of them are quite small. For example, if you have a look down here, this is where the crystal goes for the microcontroller, and as you can see, that's quite a small footprint there. You also have the SI570 is I guess notoriously difficult to hand solder. What I'll probably be doing is using my hot air gun for those more difficult components, and using a soldering iron for the remainder of the components. Most of the capacitors and resistors are 1206 form factor, so they're pretty easy to solder. I've done that many times, hand solder. I've done that many times before. And these are SOIC 14, SOIC 8 ICs for the most part. While we're talking about the components, all the other components, aside from the audio codec and the microcontroller, you have to purchase yourself. There is a complete bill of materials available, but just to note, some of those parts required are not cheap. So just a few examples there. So the SI570, the frequency synthesizer, you can pick that up from DigiKey or Mouser, but that's around about $15 to $17. There's some high current op amps that are part of the output circuitry. They're about $6 each, and you need 2 of those. You need some high quality, quite a few high quality op amps also in here. They're going to be around about $5 to $6 each. So all up, you're looking in parts at least $100 in parts. At least that's what I saw. Now, obviously, I already have a pile of the resistors and capacitors already, but I certainly didn't have the special purpose op amps.
So this is the manual that comes with the radio. It comes in two parts as PDF, and like I said, I'll include links to all the materials here. Seems to be pretty well ordered, and approaches this in the sort of the build by build module approach that I like, where you can test each component separately. So it starts off with the power supply and then moves on to testing the microcontroller and so on and so forth. So this I'll probably be following to some extent the order in this manual, but as you know, I like to do the module by module approach here. So let's walk through the schematic, and I'll just cover at a high level my approach to this, and we'll see what we see. So here's this schematic again that comes with the radio, and you can see there's 5 pages of schematic here, and let me just quickly walk through the build order that I'm planning on. So first, what I'm going to start with is the power supply circuitry, which you can see right here. There's a jack on input, there's a pair of 5-volt regulators here and here, and then there's this 3.3 volt regulator here. So should be able to build that up pretty quickly and test it. Next, I'll move on to the microcontroller circuitry. And again, so here's the microcontroller here, the Cypress PSoC. Here's the audio codec here. Now, these are both installed, but all the kind of peripheral capacitors, resistors, and so on and so forth are not installed. So I'll get those all on the board, and then I'll make sure that the PSoC's actually working. And fortunately, there's this little LED here that flashes Morse to indicate various diagnostics, so you can see what's going on in the microcontroller and make sure that everything's running smoothly. After I installed all the circuitry around the microcontroller, I'll then move on to installing the USB interface here, and you can see the USB interface consists of the jack, a couple of resistors. This is ESD protection circuitry here, so it prevents the any sort of transients, whether it's static or what have you, getting through to the microcontroller. So once this is installed, I'll be able to basically hook it up to my computer. Not quite sure whether I'll use my PC or this Linux box here, but it actually should appear as a sound card device on the computer. I should also be at that point able to flash new firmware on this, and there's 2 ways of flashing firmware to the board. You can either use the USB interface together with a special purpose piece of software, or there is an in-circuit programming interface on the board itself, so you can flash that with the Cypress proprietary flashing software. After that's installed, what I'm going to move on to after that is installing the SI570 frequency synthesizer, and then you'll recall this this pair of D-type flip-flops here. This is used to generate the in-quadrature signals for the quadrature sampling encoder and decoder. So once this is all installed, I'll be able to test with some software running on my PC or Linux box. I'll be able to test changing the LO frequency. I should be able to probe the outputs of here and here, and I should be able to see those LO signals in quadrature. I'm getting a bit far ahead now, but after the SI570 is installed, I'll be able to install the receiver circuitry here. And when I get up to this portion, I'll go into the circuit in more details. But here's the receiver circuitry. Get that working. I should be able to probe the output of the receiver here, and I should be able to see the I and the Q audio signals at this point. And then finally moving down to the transmit side, which consists of this portion here. And this is the kind of the amplifier section here. Here's those high current OPA 2674 op amps that are in the output circuitry here. And then the finals consist of this pair of RD15 HVF1 MOSFETs, in a similar configuration that we've seen before. Here's the bias circuitry coming through here. But as I said, I'll go into more details on the circuits themselves as I'm actually building them in place.
That's the plan of attack anyway. Plans might change as I get into building, and I find challenges. And like I said, I'll do a deeper dive in the relevant schematic section as I build up each module. One final note, the code running on the microcontroller is open source. I believe it's open source. It's certainly available for download and examination. If you wish to compile it, though, you do need the Cypress PSoC creator software. I believe that only runs on Windows. And I may give that a go. We'll see. And as I mentioned before, if you wish to flash it, the hex files are supplied on the main Magnis site, and you can do that over USB or using the PSoC, the Cypress PSoC programmer. And the ISP, the in-circuit programming interface for that is right here, so you can do in-circuit system programming with this. So anyway, that's the plan of attack. I think this will be a fun little radio to build up. I'm hoping to get a couple of videos out in the next few days on my progress, and we'll take it from there.